First, the team would like to give you a little bit of project background. Flexfab is a global manufacturer of high-performance silicone hoses, tubing, and ducting. One of the company's many products is a silicone bellows with stainless steel reinforcement rings for turbo air conveyance and heavy-duty and off-road engine applications. Images of these bellows are shown on the bottom right of the slide. These bellows are cut to length and then each needs to be ringed. The current state of this manufacturing process exists as follows. An operator collapses a silicone bellows by hand and places stainless steel rings in the respected convoluted valleys. The goal of this project is to develop an automated machine that can reliably facilitate the ringing process and relieve operator fatigue while also providing a safe user interface. The machine should also come with pre-configured part setups that possess the diameters of a bellows, as well as the ring size, the ring part number, and the position of the rings. Flexfab also requested that the machine included an automatic feeder system for these rings, which would allow for bulk loading by the operator for each stack. The specifications that the team was given for the machine design was the machine needed to successfully ring a single bellows in 30 seconds or less. It also needed to be adjustable for varying bellows sizes, as these bellows can be anywhere from 4 to 8 inches in length and 2.5 to 4.5 inches in diameter. It also needs to accommodate bellows with 1, 2, or 3 rings, and it needs to be able to hold 3 different ring sizes at one time. Some of the design constraints of this project was a $15,000 budget. It must not exceed a footprint of 34.5 inches by 19.25 inches, and all controller and HMI development must be completed by the team.
As seen in the previous video, collapsing the bellows in preparation for ringing is currently performed by human hands. In order to mechanize this step, several concepts and prototypes were vetted before landing on a current design, which consists of 2 rods and a collapsing bar. The 2 parallel cantilevered rods that change relative centerline distance depending on recipe selection act as both a fulcrum and grippers, while the collapsing bar rises from the underside to perform the bellows fold. Maintaining a constant centerline on the 2 parallel cantilevered rods was achieved via a Gates power grip pulley system driven by an Allen Bradley servo coupled to a Nugert 10-to-1 90-degree gearbox. The collapsing bar is driven by a pneumatic bimba thruster which folds the hose while the 2 parallel rods move inwards to pinch the hose. Just prior to the parallel rod's contact, the collapsing bar is removed in order to allow for re-expansion of the bellows at the end of the cycle. The entire drawer assembly sits on a pair of linear rails. Once closed, a safety latch and guarding ensure that the operator cannot reach inside of the machine during cycling.
The next part of the machine that we will look at is the ring dispensing subassembly. Most simply, this subassembly is responsible for dispensing the rings and staging the rings in an upright position. Designing this subassembly consisted of many challenges, such as accommodating a total of 3 stacks of rings that could vary in ring diameter and ring gauge. In addition, ring dispensing reliability, the time it would take for a single ring to be dispensed, overall subassembly footprint, and cost were heavily considered during the designing process. The final design is a compact unit that can house and dispense 3 different stacks of rings at any given time. A single stack of rings is held by 3 vertical rods that can be manually adjusted to the ring diameter. These stacks of rings sit flush on top of a slotted platform, which can also be manually adjusted to accommodate small differences in ring thickness. The assembly begins the dispensing process by powering a conveyor with a DC gear motor. The machine will determine which conveyor to power based on which stack of rings are required by the recipe. Attached to the conveyor are 2 small protrusions that move through the slotted platform and skive off a single ring with each conveyor revolution. Inductive proximity sensors are utilized with the conveyor so that the machine can identify when a revolution has been completed. After removal from the ring stack, a single ring will travel down a sloped chute and into the ring staging unit. The ring stager consists of a 3D printed staging block attached to a 3-stage cylinder. The staging block has 3 V-shaped slots so that a total of 3 rings can be securely staged at any time. In addition, a photoelectric sensor is located at all 3 ring slots to provide feedback if a ring is present. When a ring is dispensed and slides into a slot, the 3-stage cylinder will engage to the next position, which allows for another ring to be dispensed into the next empty slot. When the correct number of rings are dispensed, a pneumatic cylinder engages to securely stand the rings up in a vertical position. The vertical alignment of the rings at the exact same location during every machine cycle is critical in ensuring that the pick-and-place subassembly can reliably pick up the rings.
For the final design, a pick-and-place system was designed to place the rings. A 2-axis pick-and-place system was designed using servos, ball screws, and linear rails for precise and accurate motion. Calculations were conducted to determine the appropriate ball screw size and pitch, as well as the size of the servo motor for the X and Z axes. The pick-and-place accurately places the rings from the ring dispensing unit to the collapsed bellows in the convoluted valleys. The pick-and-place utilizes pneumatic grippers that can be independently controlled to pick-and-place 1, 2, or 3 rings based on the production need. The pneumatic gripper features hydrogenated acrylonitrile butadiene rubber pads that have excellent resistance to oils in addition to its abrasion resistance. This will ensure the stainless steel rings are held rigidly for proper placement. Accurate placement of the rings is critical to ensure a quality finished product that does not require any rework. The pick-and-place system is advantageous because of its flexibility in motion and control. With a large variety of products ranging in the number of rings, the spacing between the rings, the length of the bellows, and many other factors, the pick-and-place can accurately and efficiently place the stainless steel rings in the appropriate locations.
The team determined that the re-expansion of the bellows was critical to the fit and form of the finished product. If the bellows expanded too quickly or in a non-uniform manner, the rings would not satisfy the position specifications. In order to achieve the correct ring placement, many trials were run to determine the most efficient way to allow the bellows to expand back to its original shape while keeping the rings in their convoluted valleys. It was determined that by combining the slow linear motion of the collapsing holding rods outward and the force of gravity, the bellows was able to repeatably pop back to its original shape, all while keeping the rings in their correct positions. Once the re-expansion of the bellows completes, the drawer unlocks with the help of the safety lock connected to the PLC, and the operator is able to slide the finished assembly out of the machine. The operator will then unload the ring bellows from the 2 posts, load the new bellows, and pad print the finished assembly. Future-proofing was taken into consideration as the drawer was designed to be powered if the machine ever progressed to a fully automated state. The powered drawer provides a direct and easy loading and unloading point for a robot to perform these operations in the future.
After thorough brainstorming, development, and prototyping of each subassembly of the automatic wringer, the final designs were put together to complete an entirely new machine for Flexfab. Some advantages to our machine design are that it's small, but it's very powerful. It improves the operator's health and safety, and it's relatively low cost for its complexity. It works for most bellow sizes that Flexfab manufactures, and it could easily be integrated into an automated cell in the future state. It's also going to be low maintenance as all of the sliding elements are greaseless. The machine also reflects the current PLC hardware that's being used at Flexfab, and lastly, this machine conforms to all Michigan environmental health and safety regulations. Some slight disadvantages to our machine design is that it may complete the operation slower than the operators are currently performing it by hand. It's also capable of only 3 unique stacks of rings at a time, and it requires the operator to be present at the machine at all times. As a result of the global COVID-19 pandemic, Grand Valley State University transitioned all of its courses to an online learning environment. This meant that the team needed to rethink how to complete our project. We aimed to deliver components of the machine that could be completed remotely and still would provide a valuable basis for development of this project for Flexfab. Following the transition to online learning, the team was tasked with developing the ladder logic and operator interface for the machine, as well as creating an operating procedure for ease of use. Lastly, the team created a full simulation of the machine operating as intended if it were built. This video will be shown later in our presentation.